Question 7. A new model car is available in 4 exterior colors and 2 interior colors. Use a tree diagram and specific colors to show how many color schemes are available for the car. All right, so I'm going to do this tree diagram vertically because I have a little more room to spread out. And so this is my car. Okay, so we're going to start and 4 colors, and we'll just name some colors. So for an example, I could have a red car. I could have a black car. I could have a gray car. Just need 4 colors. Or I could have an orange car. Don't see many orange cars, but you could. All right, now for interior colors. Each of the exterior colors can have an interior color. Now these interior colors are going to be the same. So we're going to say black or white. It could be any color, but let's just keep it consistent. Okay, and that's the end of this tree. And here we could have a black interior. You know, it has a black exterior, but it could have a black interior too. It could be black on black, I think is how they would say that. Or it could be white. Okay, and for the gray interior, it could be black. Or it could be white. And for the orange, it could be black. Or it could be white. So when you look at it, I could have a gray car with a white interior. I could have a orange car with black interior. So there are lots of different options, but in the end, when we put it all together, there are eight color schemes. For the car. Number 8. Students were divided into 10 teams with 12 members on each team. Later that same day, students were divided into teams with 4 on each team. How many teams were there then? Okay, well, we could do this a couple of different ways. If I had 10 teams and there were 12 members per team, well, that would end up giving me 120 members total. Now, if there are 120 members and there are 4 members on each team, that ends up giving me 30 total teams. Number 9. Perform the following multiplication using let's create our lattice. So I'm going to create, let's get a pen here, create my lattice, a little smaller, and write my answers out. And I'm going to do 167 across the top and 29 on the bottom. And then do the multiplication every quadrant. As an example, with the 7 and the 2, we get 14. 7 times 9 is 63. 6 times 2 is 12. 6 times 9 is 54. 1 times 2 is 2. And 1 times 9 is 9. So add that along the diagonal. In this diagonal, we get a 3. In this diagonal, we get 14. So I'm going to put a 4. I'm going to carry a 1. Along this diagonal, we end up with 18. So I'm going to write an 8, carry a 1. And with this diagonal here, I end up with 4. So using the lattice multiplication, I get 4,843. Moving on to number 10. It says perform each of the following. And we could use lattice with this first one as well, if we want. It's kind of nice and simple to put together here. So 32, 3. You could also use vertical multiplication. But 3 times 2 is, well, that'd be 6 if we were in base 10. But it ends up being 12 in base 4. Because there's 1 4 in 6, and then it'll be 2 left over. 3 times 3, well, in base 10, that's 9. But in base 4, that's going to be 21 because there are 2 4s in 9 plus 1. And when we look at this and we do our addition, we get 222 base 4. All right, now from B, 110 divided by 2 base 5. Well, I have 2 goes into 1 0 times. And when we're on base 5, so 2 goes into 11. All right, well, we could do this with some repeated subtraction if we like. I'm going to give myself a little more room here. All right, so if I subtract 1, 2, okay, well, that 11, right, that's actually equal to like a 6 in base 4. So 11 would be a 6 in base 10. So what we end up with is a 4. And you can use a number line, right, if we want to look at that subtraction. And then, so that'd be a 1 term, right? It goes in there 1 times. And then I know 2 goes into 4 2 times. So 2 goes into 11 base 5 a total of 3 times. Okay, just repeated addition, just repeated subtraction. And then we'd have to bring down the 0. Because 2 goes into 0 0 times. So 110 base 5 divided by 2 base 5 is equal to 30 base 5. Moving on to number 12. Use the